Okay, Bismillahirrahmanirrahim. So, the first topic that we would be discussing today is how MEMS are fabricated. So, as you know that in engineering, the first phase of making a product is the design phase. So, we would start with the device design, and in the design, you have to first select the mechanism. What should be the mechanism for the device? Whether the mechanism would be electrostatic, it should be based on piezoelectric, electromagnetic, uh, thermoelectric, fluidics, etc. In the design phase, depending upon the problem which you want to solve, meaning that for which you are making a sensor or actuator, microfabricated sensor or actuator, so first you have to visualize or think that which mechanism would be suitable. And once the mechanism is decided, the design phase, then you have to do the mathematical modeling, system analysis. You have to perform system analysis. We have to do modeling, mathematical modeling. We have to develop the mathematics of the device. And you have to decide about the dimensions. What should be the dimensions of the different parts of the device? What should be the thickness? What should be the shape of the beam? What should be the length of the beam, etc. And you have to develop the mathematical equation. And then you have to simulate it in order to see whether the design which I am selecting, whether it is working as per our requirement or not. If it is working, then you have to go to the next phase. If it is not working, then you have to go back to the device design. And you have to change, let's say you have to change the mechanism. Previously, you have selected electrostatics, and through modeling and simulation, you come to know that it's working or performance would be not as per our requirements. So you have to go back to the device design phase, and you have to rethink again about the mechanism, about the shape, about the architecture, etc. And you have to again do the modeling and simulation. And in the modeling and simulation, you have to check the performance. You have to predict or estimate the performance before the actual fabrication. If it is as our desired, then you have to move to the next phase. And the next phase is actually the process design. You have to decide about the process design. Process design, you have to think about which processes would be used to fabricate this device. What would be the processes? What would be the machines which would be used to fabricate those processes? Whether those machines are available with you in the clean room or not, whether those processes are feasible or not, whether somebody has produced some fabrication processes or invented some fabrication process for the development of this particular layer of the device, or you have to make your recipe of the process by yourself. So you have to decide all those things in the process design. So इस device को हमने fabricate कैसे करना है? How to fabricate? What would be the processes? On which machines we have to perform the processes? What thicknesses we have to add? So all you have to decide about that in the process design phase. Once that is done, and during the process design phase, you have to collaborate. You have to collaborate in between. You have to move or go to the modeling and simulation. Modeling and simulation may actually you would have decided about the the sizes of the different parts of the device. As I already discussed with you, that the thickness of the beam, shape of the beam, size of the beam, thickness of the membrane, thickness of each layer, etc. Then once that is decided, then you have to do the fabrication. And normally the microfabrication or MEMS fabrication is done in the clean room. clean room is the place where it is free from dust and dirt because we are fabricating on very small scale, micro scale, nano scale, and the dust particle, the minimum size of the dust particle ranges from 1 micrometer to 5 micrometer, 10 micrometer. So that could ruin your device or fabrication. Normally, the fabrication is done inside the clean room. In the coming slides, we would be discussing that what is the environment of the clean room and what equipments are there. वो अभी आगे discuss करेंगे. Next, once the device is fabricated, then you have to initially test your device. The initial testing is the visual test, which could be done under the microscope. Inside the clean room, you would have a microscope, and under the microscope, you have to visualize the fabrication process. Scan electron microscope could be also there. You could even also do the visualization testing to scan electron microscope. And you could take photographs of your product under that. And afterward, there will be a propagation. The propagation you have to apply certain voltages or currents to the device, and you have to measure the displacement, velocity, or sensitivity, etc. So this is actually how you go through the fabrication of a micro fabrication device or MEMS device. Okay, next is clean room. Fabrication of MEMS and NEMS, that is micro fabrication and nano fabrication, are actually normally done inside a clean room. The place free from dust and dirt. Clean room air is cleaned from dust with HEPA filter. HEPA stands for high efficiency particulate air filter. So throughout the ceiling, we have filters, clean room, through which we are passing the air which is coming inside the clean room, and we are cleaning that air. We are removing the dust particles, dirt particles of the air. Inside the clean room, we have a clean air. User put proper clothing in clean room. Dangerous chemicals are used carefully and disposed properly. So we are using strong acids, strong gases, other hazardous chemicals and fluids, which will be very, very harmful if you come in contact with those. So normally they are handled very carefully, and there is a standard procedure for the disposal of. This is how you look like when you enter the clean room. So you are not allowed to enter the clean room without this suit. So this actually outfit composed of coverall. This is the coverall. This is the coverall and safety glasses, hair net, face mask. You have to also put a badge. Either you have to put a badge or you have to write your name because your face will be covered. So nobody would recognize you. So you have to put your name there so that people inside the clean room can recognize you. And if there is some thing, for example, a various thing or dangerous thing, or if you are working not properly, then they would call your name. So there should be a name or page here. Nitrile or latex gloves or shoe cover. So this is the proper dress which you have to put while by entering inside the clean room. So normally in the clean room we have this is the bench. On this side, this is the dirty. This is the gowning or changing room. So normally you are not allowed to come here without this. You have to change this specification. So initially, when you are entering inside the clean room, so you have to start from the top. From the top, we mean that first you have to put the hairnet, then you have to put the mask, you have to put the coverall, you have to put the shoe cover, you have to put the tactile gloves. You have to start from the top. And when you are coming out of, when you come out of the clean room and you want to change, you need to start from the bottom. First, you have to remove the shoes or shoe covers. Then you have to remove the coverall, and you have to dispose of the gloves. You have to remove the coverall, face, mask, and yeah. The reason for that is actually, as we discussed last time, that dimension, that the diameter of the hair, human hair is 100 microns. So if you put the coverall first and your hair falls on your coverall and you enter the clean room and you start the process and the hair from your coverall fell down on your silicone wafer, and it would ruin all of your previous work, all of your device. So also in here there is dandruff, and the particle of the dandruff would be 10 micrometer to 50 micrometer, 60 micrometer. If it falls on your coverall and then if it falls on your wafer, silicon wafer, it would ruin your device. Initially, when you are entering, you have to start from the top. First, you have to cover your hairs, and afterward, you have to put all those things. When you are coming out, you have to start from the bottom. This is the standard procedure for changing the dress coming in and going outside the clean room. Normally, the clean rooms are classified by clean room class 6. And what we mean by the clean room class is the number of zero point 0.5 micrometer size particles define the class of a clean room. That is, there are so many number of 0.5 micrometer size particles inside the room that actually decide about the size, about the class of the clean room. For example, here you could see this column is about the class office, ordinary office, and we have 100,000 class, 10,000 class, 1,000 class, 100 class, 10 class, 1 class, 0.5. And this column is there we see 0.5 micrometer particles per cubic feet. There are how many numbers of 0.5 micrometer particles per cubic feet. In 1 cubic feet, there are how many number of 0.5 size particles. So if there are 100,000 uh, 0.5 micrometer size particles in 1 cubic feet, then the class of that room would be 100,000. If in 1 cubic feet there are 10,000 0.5 micrometer size particles, then the class would be 10,000. If there are only 1,000 0.5 micrometer particles, the class size would be 1,000. Similarly, if the number of 0.5 size particles is 100, 1 cubic feet, then the class would be 100. If there are 10, class would be 10. If there is only 1.5 micrometer particle in 1 cubic feet of the room, then that class rating will be 1. And similarly, 0.5 means very small number of particles in 1 cubic feet, so 0.5. Then the class rating will be 0.5. Also, you could see beside 2.5 size particles inside the room, there would be other size particles, for example, 5 micrometer size particles per cubic feet. Those are allowed in these class ratings. 100,000, there would be 650, 10,000, 65, 1,000, 6.5, 100, 0.65, similarly 0.5, 6.003. Air changes per hour. How many times you have to completely change the air inside the room, meaning that you would be continuously doing the ventilation inside the clean room. Reason? Because we are using hazardous and toxic acids and bases, gases, etc. And we don't want that those toxic fumes damage or harm the people who are working inside the clean room. So normally we have to continuously change the air or ventilate the air in the clean room. So there is this is the standard for each class rating. Normally in office we need 12 to 18 air changes per hour. In 100,000 class it would be 18 to 30 air changes per hour. Similarly, 40 to 60 for 10,000, 150 to 300 for 1,000, 400 to 540 for 110 class rating, 540 to 600 for 1 and 0.5 class rating clean. Ceiling filter coverage, as I told you before, that normally we remove the dust particles, dirt particles from the air with the filter, and those filters are actually installed inside the ceiling of the clean room. And the more the size or the area of the ceiling covered, the more would be the more clean would be the air inside the clean room. So ceiling filter coverage percentage for 100,000 plus, 10% area of the ceiling will be covered. 10,000 plus, 30% will be covered. 1,000, 50% will be covered. 100 class clean room, 80 to 100%. Similarly, 10, 1.5, the 100% area of the would be covered with the HEPA. Air velocity, also we must have a standard air velocity inside the clean room. Air would be blowing through these filters, but those could be coming down with a certain velocity, and these are the velocities with which that air has to move or come inside the clean room. Maximum vibration, micro inch per second. There should be minimum vibration inside the clean room because you would be using equipment, you would be doing fabrication, and the vibration could ruin your fabrication. So there should be as much as minimum or no vibration. However, we would be using equipment, machines, motors, spinners, etc. So there would be a very slight vibration, but these sort of vibrations are allowed. You could tolerate these vibration. For example, in 0.5 plus 125 micro inch per second, vibration is tolerable. And temperature tolerance. The comfortable temperature normally for human being is 22 degrees centigrade. So normally the temperature inside the clean room is around 22 degrees centigrade. Temperature tolerance means plus minus. It could be plus minus. So plus minus 3, plus minus 2, plus minus 1, plus minus 0.5 plus minus 0.3 degrees centigrade plus minus 1 degree centigrade. So these class ratings, it is accepted. Relative humidity is also very important. Normally we keep around 60% humidity inside the clean room. This is the relative humidity tolerance. Super नीचे हो सकती है. So point plus minus 1 4.5 class rating and 2% for one class rating and so on. Approximately capital cost per square feet. The ordinary office capital cost per square feet is $10. But as you put the filters and other equipment inside the clean room, so the capital cost of the room would increase. For 100,000 class, the capital cost is $50 per square feet. 10,000 capital cost increases to 200 to $250. For 1,000 class, the capital cost increases to 350 to 400, whereas to 100 class, capital cost is approximately 1,200 per square feet. 10 class, $3,500. For class 1 rating, it would be around $10,000 per square feet, whereas for 0.5 class clean room, capital cost would be $25,000 per square feet, meaning that the more class you want, the more high class rating clean room, it would cost you more. Here you see some figures, which is about the air cleanliness. So normally two standards are followed. One is the US standard and the other is the Japanese standard. This figure is air cleanliness according to US Federation standard 209E, and this figure is air cleanliness according to Japanese standard B9920 device. So here you along the vertical axis you see the total particles per cubic meter, and here you see total particles per cubic meter. The number of total particles in cubic meter space, and this is the class. This is class. Japanese they use class 1, class 2, class 3, class 4, class 5, class 6, 7, and American is M1, M2, M3, M4, and 6 and 7. So they use this terminology. And normally we also use the terminology which we already discussed: 10,000 class, 1,000 class, 100 class, 10 class, 1 class. And we also use that terminology for the clean room rating. And the horizontal axis is the particle size, 0.01, 0.11. So this is the particle size. So 1.1, 0.01 particle size. So normally we could find out that how much would be the number of particles. Let's say if we are saying that how much would be the 1 micrometer particle in a clean room.